Hello, good morning. Here is our next section. It is about inequalities. No homework today, so you should spend some time today catching up on old homework. Inequalities are not equalities. Equalities have an equation. Inequalities are really popular in life because not everything has to equal something. Sometimes you're more than something, or sometimes you're less than something. For instance, Grayson only has $70 to spend. Well, he doesn't have to. If Grayson's going to the movie theaters, he doesn't have to spend exactly $70. That's not really realistic. He literally has $70 to spend in the movies, so he'd be very happy spending only $5 at the movies. He just can't spend $71. He can't spend $72. He can't spend anything more than $70. So that is your inequality. If you say the words more or less or at least, inequality might be in the air. So let's get down to it. Grayson has some kids. He's going to the movie theater. A bag of popcorn costs $7.50 each. A bag of candy costs $5 each. And he has only $70 to spend. He must buy a minimum of 10 bags of food. So there's that word minimum, which I think is the first time that word's been mentioned in this class. So, is it possible for X to be 3 and Y to be 12? So 3 bags of popcorn and 12 bags of candy? Yeah, that would be 15 items. So, that's at least 10. Could he have 10 bags of popcorn and 1 bag of candy? Yes, that's 11 bags altogether. That's more than 10. Could he have 50 of each? Yes, that's 100 things in total. So, that's at least 10. So far, here are 3 scenarios for Grayson. Unless his kids are extremely, I don't know what the word is, 50 bags of popcorn, 50 bags of candy. No. So X plus Y has to be at least 10, greater than or equal to 10. All the bags of popcorn plus all the bags of candy has to be bigger than 10 or equal to 10. And we're going to graph this. So we solve for Y, you subtract X, and this is one thing. We're halfway there. This is one thing that we're going to graph and give a solution. Now, because it's an inequality, it's not a function anymore, because there's an x value that's going to produce a ton of y values. That's a solution here. There are lots and lots of ordered pairs. We're not going to just find one. We're going to find many of them. And so the solution will always be a graph. If you have inequalities, the solution will always be a graph. All right, he only has $70 to spend. So could he buy 4 bags of popcorn and 12 bags of candy? We were told that it's $7.50 per bag of popcorn, $5 per bag of candy. Well, you get your calculator out. And looking at that, I see that 750 times 4 plus 5 times 12 is 90. So the answer is no. That's not good. He can't do that. He doesn't have $90. What's another solution? He could buy 8 bags of popcorn and 1 bag of candy. So you go to your calculator, 750 times 8 plus 5 times 1, and that equals 65. Okay, that's a possibility. Hold on a second. That's only 9 items. 8 bags of popcorn and 1 candy. That's only 9 things. So he has enough money to do that, but his kids are going to tie him up to the armchair and set his toes on fire or do whatever children do. So we need at least 10 bags of stuff. And this is only 9 bags of stuff. But he has enough money to do it. What is the equation here? Well, look at the thing that's changing. The thing that's changing is the 4 and the 12, the 8 and the y. Change, another word for change is vary. So that's where your variable goes. It'll be 750 times x. So 750 per bag of popcorn plus 5 times y. That has to be no greater than 70. It has to be under $70 because he only has 70 to spend. And then you solve for y. So I subtract 750, you divide by 5, and you have a second constraint. And these are the only constraints for Mr. Grayson. He only has $70 to spend. So this is your money constraint. And he has to buy at least 10 items. So this is like your amount constraint. So can you imagine in your head an X and a Y that satisfies both this and this? Neither can I. That's why we'll use math to our advantage. We will graph these two. So we are going to graph. We'll pick pea green soup right there. For the amount, I start with 10, and the slope is -1. Don't tell me that the slope is -1x. No, 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 no. The slope is -1. The slope is a number. And then we'll go to a lilac color for the money situation. First of all, this is the amount. So any ordered pair exactly on this line, Mr. Grayson will have 10 items exactly. Anything above this line, he will have more than 10 items. And that's what he wants. He wants at least 10 items. The second equation has a y-intercept of 14. So I start at 14 and a slope of -3/2. So down 3 over 2. 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 Oh, I went too far. Over 2. That lilac colored one is the money situation. If you have an ordered pair exactly on that line, he has spent exactly $70. Anything above that line, he's spent more than $70. Anything under the line, he's spent less than $70. So, this ordered pair right here, any ordered pair over here is he bought at least 10 things, so that's good. The kids are happy, but he spent more than $70. So he doesn't have the money. Anything over here, what's the problem with this? It's less than $70 because it's underneath this blue line, but it's also under 10 items. So he wants to buy at least 10 things. So only the ordered pairs in here. Any ordered pair in this region right here is a solution for Grayson. Any ordered pair in here. Any ordered pair in here will have at least 10 items and be under $70. So for example, the solution is the area or the region in between the two lines where the blue dots are. Bear with me, guys. For example, a solution is, what's an ordered pair in that region, guys? Pick one. Say it out loud. Okay, good. 3 8. 3, comma 8 is in there for sure. 3 8 is a solution. What does that mean? X is 3. So that means that Grayson bought 3 bags of popcorn and 8 bags of candy. Notice 3 plus 8 is 11, which is more than 10. The total price is, let's see here, $7.50 times 3 plus 5 times 8 equals, go to your calculator. Let's see here, $7.50 times 3 plus 5 times 8 is $62.50. We got it. Any ordered pair in here will work. More than 10 items, under $70. One more example to go. This one has 4 constraints. Claire owns a food truck. She only can make 120 tacos or burritos. Okay, she sells tacos for $3, burritos for $5.50. She must sell a minimum of $440 worth of stuff. And she must sell at least 20 tacos and no less than 60 burritos. Wow. That's 4 things that Claire has to watch out for. She can only make a maximum of 120 items. She needs to sell at least $440 worth, at least 20 tacos, and at least 60 burritos. Oh, yeah. Let's talk about the money first. X represents the amount of tacos. So $3 per taco, per implies multiply. So that's 3 times X. $5.50 per burrito, $5.50 times Y. So 3X plus $5.50Y, that will be all the money that she sells, all those the amount of money that she earns or sells or whatever. All that money has to be, well, a minimum of 440. So which one is it? Which situation says that the minimum that she sells is 440? And it is the top one. In other words, a minimum of 440. In other words, at least 440. If you go to a job interview and you say, I need to make a minimum of 40,000 a year, that means anything above 40,000, or either equal to 40,000 or above 40,000. So this is all the amount that she's selling. That has to be greater than or equal to 440. Now, could x equal 7? Is it possible that x equals 7, knowing that x is the amount of tacos? Answer, please. The answer is no. She has to sell at least 20 tacos. So 7 tacos is not going to cut it. And since x represents the amount of tacos and she has to sell at least 20 of them, x must be greater than or equal to 20. Could y equal 72? Knowing what y equals, could y equal 72? The answer is yes. She has to sell no less than 60 burritos. So 72 is not less than 60. So 72 burritos would work. She has to sell at least 60 burritos. So y has to be greater than or equal to 60. Could x equal 100 and y equal 100? Oh, she would make so much money. 3 times 100 plus 550 times 100. That would be way more than 440. Is that good for Claire? That would be awesome for Claire. Can she do it? Can she do it? No. She only has enough supplies to make 120 items. So that's 200 items. She can't do it. She only has enough tortillas and cans of beans and stuff like that to make 120 items. So all the tacos plus all the burritos has to be less than or equal to 120. Wow. So we've got these 3 constraints. Constraint number 1, the money constraint, the taco constraint, the burrito constraint, and the total amount of materials constraint. So we're going to graph 4 things. And we have to find an ordered pair that satisfies all 4. Before we do that, we have to do a little bit of algebra. Here's that first equation, the money equation. I solve for y. Here's the amount equation. I solve for y. And now we're going to graph. So let's do red. It has a nice pop. First of all, let's do x is greater than 20. Here is when x equals 20. So everything on that line, any ordered pair on that line, Claire sold exactly 20 tacos. But she has to sell at least 20 tacos. So any ordered pair on this line or to the right is good. Like over here, she sold 70 tacos over here. Over here, she sold 150 tacos. Y has to be greater than or equal to 60. So here's when y equals 60. Every ordered pair on that horizontal line, y is 60. And to be more than 60, talking about y now, you would go up. So any ordered pair up here is more than 60. All right, so right now, all these ordered pairs are solutions for Claire. She's selling more than 20 tacos and more than 60 burritos, but there's more. First of all, the money constraint. She wants to sell at least $440 worth of stuff. And that's this equation right here. So I'm going to start at the y-intercept of 80. And my slope is negative 6/11. So I go down 6 and over 11. And that's about right there. So any ordered pair on this line, what does that mean? Any ordered pair on this line means that she sold exactly $440 worth of stuff. And she wants to sell at least $440. So any ordered pair above this slanted line is good for Claire. And then finally, the materials constraint. She can only make 120 items at all. And here is this equation. So I go up to 120 and my slope is -1, so I go down 1 over 1, down 1 over 1, down 1 over 1, and I get right there. So you tell me, where are the ordered pairs that satisfy all four constraints? They are all in here, my friends. Any ordered pair in here will be a solution for Claire. It'll be at least any ordered pair in here, think, has more than 20 tacos, because it's to the right of this, has more than 60 burritos, because it's above this, makes more than $440, because it's greater than this line, and it's less than 120 items, because it's under this line. So the solution is any ordered pair in the region where those blue dots are. For example, what's an ordered pair in there? 40. Okay, let's do 42, 65. 42, 65 will work. 42, 65 is in there. For example, 42, 65 is a solution because that's x is 42. So 42 tacos is more than 20. 65 burritos, oh, I'm getting hungry, is more than 60 burritos, right? 42 plus 65 equals 107, which is less than 120. Remember, she can only make 120 items of food in total. And now the money. Did she make at least $440? Let's see. 3 times 42, $3 per taco, plus $5.50 per burrito is 3 times 42 plus $5.50 times 65 is $483.50. So there it is. Please, I hope this went well. Please watch it again, and we should have a second test coming up soon, probably next week.